Hello and welcome to this tutorial for VRED Core. I'm your host Christopher, and today I will show you how you can create a simple custom HTML interface for your VRED Core application. VRED Core was developed to suit a variety of different needs, from providing a rendering pipeline to data preparation or acting as a dedicated real-time rendering server. It covers a whole range of use cases. Because VRED Core does not provide a user interface of its own, we are bound to communicate with it using the Python web interface. VRED Core does come with a streaming app, however, that gives you access to all functionality you would need for a product presentation or design review. The streaming app enables you to access all variant sets and viewpoints in your scene and also allows you to freely navigate with the camera. This is fine for a lot of applications, but VRED Core also offers tools that allow you to build a fully customized HTML user interface yourself. That means you can build an application that exactly serves your needs and can be branded with your corporate design. In this tutorial, I will show you how you can build your own VRED app, including a live video stream, a simple Python terminal, and a list of your variant sets. To establish a communication with VRED, we will use its Python endpoints. We start by creating an HTML document that just contains a simple text paragraph. This document cannot be named index.html because VRED already has reserved that name. Therefore, we just call it myapp.html. Next, we need to set up our web interface preferences. This can be done by starting VRED Core with the command line parameter edit preferences. We switch to the web interface preferences tab and set the following settings. We enable file access and set the directory to the directory where your custom app is. At the bottom, we enable allow cross-origin requests. Please note the port number when you set it to something other than 8888, because we will need it to make Python requests to VRED. These settings will initialize VRED's web interface, and we can test the settings by running VRED Core and opening a browser at the port provided by localhost and the file myapp.html. We should now see our example text and know that the web interface is working correctly. After that, we can switch back to our editor and continue to implement our app. At first, we want to implement a live video stream with navigation. There are different ways to do this, but for simplicity, we can use the stream that is provided by the endpoint apps VRED stream. This endpoint provides a live video stream and the default navigation behavior we know from VRED Pro and Designer. We can use this endpoint as a source for an iframe that we can configure to cover the whole page. To do this, we create a script tag in our document where we will add some JavaScript code. We create a function initializeStream that searches for an element with ID streamContainer and sets its source to our streaming endpoint. Here we are using the port number we set in the web preferences. We call this function in the window onload function to make sure the stream is always initialized when the page is loaded. Of course, we also need an iframe element with a matching ID attribute that will show this video stream. With some CSS, we can define the size of the iframe to be 100% and prevent that any borders or scroll bars are visible. Let's reload our app in the browser and see if our stream is working correctly. Nice! We now have a live video stream to VRED and can navigate the scene with the mouse. Having a live video stream is a first step, but of course we also want to implement some interaction in our app. For this tutorial, I want to integrate a simple Python terminal that allows us to send Python commands to VRED to manipulate our scene. We start by adding a few new div containers that allow us to position the Python terminal over our video stream. Then we add a text input and a button to send the content of the input element to a JavaScript function. I also want to show any return values that VRED is sending back, so I add a text area below the input field and button. We can style these new div containers so that the Python interface is positioned in the lower right corner of the browser window. To send Python commands, we can create a new function in our JavaScript area called send and receive Python. This function uses a XML HTTP request object to send a GET request to the Python endpoint Python eval2. This endpoint accepts Python commands and also returns the result of the Python operation as a string. At this point, I also want to store the port and the host in separate variables that they are easy to change in the future. Be sure to encode your Python commands as a URI so that VRED can understand it. We also use success and error callback functions to be more flexible. The success callback will be called with the response of our GET request, and the error callback will be called in case of an error. Next, we implement the function execute terminal code that actually sends the Python command to VRED and attaches the result message to our text area element. We just have to call this function when the submit button is clicked and pass the content of the input field as a parameter. When we wired everything correctly, we should be able to send simple print commands to VRED or request all variant sets from the scene. The list of variant sets is also shown in our Python terminal window because VRED returns a list of them with the return message. We saw that we can get a list of all available variant sets in our app, so why don't we show them in the interface and make them selectable? Let's create a new JavaScript function called update variant sets. In this function, we call our send and receive Python function with the Python command get variant sets and provide a callback method for the response. For now, we just want to print the variant sets to the console. We call this function in our window onload function, reload the web page, and can open the console of the web page by pressing F12 in our browser. When you reload or open the page, you now see the list of variant sets in the currently loaded scene. When there are no variant sets, you will see an empty array here. Here I'm testing with the Genesis example from VRED that includes a variety of variant sets. Our app already receives all variant sets as a list, but we also have to add them to our HTML. In the next step, we add another div container with the ID variant set container to our HTML. This container will hold a list of all the variant sets that we receive from VRED. Back in our update variant sets function, we first have to pass the variant set array as a real JavaScript array with the eval function. Then we get a reference to our container with the getElementById function. We can iterate over the variant set array and create a HTML element node and then append this node to our container. We also want to be able to click on the variant set name to select it in VRED. To do this, we can add an onClick function to the variant set node. Whenever a user clicks on a variant set, we call the send and receive Python function with the parameter select variant set and the name of the variant set. Then we add some CSS to place our new variant set list on the page, this time on the left side. When we reload the page, we see a list of variant sets on the left, and when we click on one, the variant set is also selected in VRED. In this tutorial, we built a fully customized streaming app from scratch with the help of a little HTML, JavaScript and CSS. VRED Core offers multiple endpoints we can use to add a live video stream with navigation and change or request data in VRED with Python commands. There are so much more possibilities, but covering all would get out of scope here. In our next tutorial, we will extend our HTML app and implement some more features using the Web API. That's it for today. Thanks for joining me and see you next time.